In this video, we are going to continue with continuous random variables. That's weird, and look at expected value and the variance. Really quick, these are just formulas that are given. We're not going to look at where they came from, how they were derived, but there's the expected value formula for a continuous random variable, and the variance, I often just write V, even though you could see in this example here, it says compute the variance, right? VAR. Either way works for me. Okay. So the first one, we're just going to look at exactly like how do you use this formula. So we have this function, right? And the expected value, all we do is we take this interval from a to b, so 0 to 6, and we multiply the function by x, 1/18 x multiplied by x dx. So 1/18 x squared. So 1/18 is constant, we could just pull that out. 0 to 6 x squared dx, okay, which is x to the third over 3. So we have the 1/18. We'll go ahead and pull out the 1/3 as well. X to the third, evaluate it from 0 to 6. So this is 1/54, 6 to the third minus 0 to the third, which is 216. So we get 216 over 54. And that gives us 4. Alright, in the variance formula now, notice we still need f of x, and instead of just x, we have x squared, but we need the result from the expected value. Okay. So the variance range is still 0 to 6. Oops. X squared multiplied by 1/18 x dx. Subtract our e of x squared, so we got 4, so subtract 4 squared. Right, this integral is fairly similar, 1/18, it's pulled out, but now we're integrating x to the third, so that's x to the fourth over 4, so 1/18 times 1/4, x to the fourth, from 0 to 6, whatever we get, subtract 16. 18 times 4 is 72. 6 to the fourth minus 0 to the fourth. 6 to the fourth, just use a calculator. We get 1 over 72 multiplied by 6 to the fourth, we get 18. And then, so all of this here, okay, 0 to the fourth we didn't even need, right? We get 18. And then subtract the 16, so the variance is 2. Alright, so in this range, 0 to 6, if this is our probability density function here, we expect to get 4 on average, right? We could think of expected value as the average. And the spread, right, the spread is 2. Seems reasonable. Alright, this next example I wanted to look at, because you might see this word pop up here and there, like instead of a probability density function, it says a beta probability density function. So what the heck is that? That's just a certain parameter that we're given. This beta, they give it a special term because it pops up so much. It's pretty frequent application, and that's when x ranges from 0 to 1. So if we look at this application here, this word problem, the newspaper publisher estimates that the proportion x of space devoted to advertising on a given day is a random variable with that beta probability density function. Okay. So the proportion of space, I cannot go beyond 1, right? I cannot go beyond 100% of a certain advertising space or space devoted to advertising. I could range from 0, right? Don't leave any space for advertising, or the full page 100% advertising. All right, and again, the 0 to 1, that we call that a beta probability density function. Okay, A. Find the cumulative distribution function. Remember, the cumulative is taking this PDF and changing it to where we know the total at any given point. And in order to do that, we need to integrate. So we call the cumulative function a capital F because we're integrating this function, 30x squared 1 minus x squared dx. Now, I don't see any u substitution right off the bat, so I'm just going to go ahead and FOIL this thing out. This would be 1 minus 2x plus x squared. Okay, and then distribute in that 30x squared. So we get 30x squared minus 60x to the third plus 30x to the fourth dx. All right, integrating this, we have 30x to the 3 over 3 minus 60x to the 4 over 4 plus 30x5 over 5. And I need to backtrack a bit. We're not, if we range from 0 to 1, I mean, we should get the whole amount. So my bad here is, I just noticed that. I'm like, something doesn't look right. Okay. We're trying to find this function, right? I don't know what the cumulative distribution function is. So we are integrating, and when we integrate, we put this plus c, and then we use the fact that I know that if I substitute 0, I should get 0, right? Because at the very beginning, that probability is 0. Or f of 1, the end should equal 1, right? It's just this one is much easier to use most often. So if I substitute 0 for x, I would get all of these are just 0. So I get c. But I know that that should equal 0. So therefore c is 0. And therefore c I don't even need in this cumulative distribution function because it is 0. So let's go ahead and reduce this though. 30 over 3 is 10, 60 over 4 is 15, and 30 over 5 is 6. Okay. That is our cumulative distribution function. So therefore for B, when it says find the probability that less than 25% of the newspaper space on a given day contains advertising, so the probability that x is less than or equal to 0.25. Well, using the cumulative, right, that means all the sum of everything up to that 0.25. So we can just substitute f of 0.25 or 1/4, whatever, if we want fractions or decimals, doesn't matter, into the cumulative distribution function. So 10 multiplied by 0.25 to the third, minus 15, 0.25 to the fourth, plus 6 times 0.25 to the fifth, and I'll just get a calculator. I went ahead and did this beforehand because I knew I couldn't compute that. And as a fraction, 53 over 512. If you want a decimal, I'm just looking at it's about 10%, but just use your calculator for an approximate decimal answer if that's what is needed. All right, moving on. Now we're computing e of x and giving an interpretation, and then d, the variance of x. I'm going to go ahead and scroll sideways, that way we could still see the formulas. So C, we need E of x, and then D, we need the variance of x. So using this formula, now we go back to f of x, right? So now we're ranging it from 0 to 1. Now we need that integral. X multiplied by f of x. Well, let's go ahead and use the distributed out f of x, right? That was this here. So 30x squared minus 60x to the third plus 30x to the fourth. So 30x to the third minus 60x to the fourth plus 30x to the fifth. Okay, pretty basic integral again, just a polynomial. So 30 over 4 x to the fourth minus 60 over 5 x to the fifth plus 30 over 6 x to the sixth, range it from 0 to 1. Okay, we like the 0 and 1, right? So substitute 1, all those x's are 1, so we just get 30 over 4, which is 7.5, minus 60 over 5 is 12, plus 30 over 6 is 5, and if we substitute 0, right, all of this would be 0. So now we get 12.5 minus 12, so we just get 1/2. Okay, the expected value is 1/2, right in the middle. So what does that mean? Interpret it. So on average, half the space is devoted to advertising, or dedicated to advertising. Okay. D, compute the variance, so compute the spread. What's the range of this data that we have? So x squared, I think we could just do that part in our head, right? We're taking x squared and multiplying by this function here. So basically this e of x, we have an extra x. So 0 to 1, 30x to the fourth minus 60x to the fifth plus 30x to the sixth. Right, because this was f of x right here, f of x times x, and I need fx times x squared, so therefore all the x's just get an extra one. Okay, dx, and then subtract your e of x of 0.5 squared, right? Straight from this formula up here. Okay, integrate once again, so 30 over 5x to the 5 minus 60 over 6 x6 plus 30 over 7 x7 minus 1/2 squared, or 1/4. Oh, and again, ranging this from 0 to 1. Okay. So again, all of the extras just become 1s. So we just have 30 over 5, which is 6, minus 10, plus 30 over 7. It doesn't reduce, and it's an irrational decimal, right? So I'm just going to leave it like that, minus 1/4. And this would be -4, so -28. Anyways, I mean, you could use a calculator, but we get 2/7 for all of that here, minus 1/4. LCD of 28. We would get, overall, we get 1 over 28 is our variance.